Hello and welcome students. We are in the lecture of application of derivatives and this is question number 13 we are solving. This is question number 13 from the first exercise, that is 2.1. This question is based on, we are applying the concept of derivative on rate measure, or you can say problems on related rates. So we are continuing with the same. And in this kind of questions, what we have, we will have two variables, say variable 1 and variable 2. Variable 1, say variable 1 depends on variable 2. Okay, so this variable depends on variable 2. We are given the rate of change in variable 2. This is given to us. And from this data, we have to find the rate of change in variable 1. So we are given one kind of rate of change. We have to get the another kind of rate of change when one kind of variable is related to another kind of variable. So let us solve this problem. So here the question number 13 is, a man of height 2 meters walks at a uniform speed of 6 kilometers per hour away from a lamppost of 6 meter high. Find the rate at which the length of the shadow is increasing. See, what are the points to be noted? A man of height 2 meters. Okay, the height of a man is 2 meters. He walks at a uniform speed. The rate at which the man is walking is 6 kilometers per hour. And he's walking away from a lamppost. This is another important data. He's walking away from the lamppost. Okay, and now you know that if you are walking away from a lamppost, then the length of your shadow will increase. The length of the shadow will increase. Okay, what more is important? Another important thing here is the height of the lamppost. Lamppost height is also important because how high the lamp is, it will decide the length of the shadow. So these are the given data, and then what they are asking find the rate at which the length of the shadow is increasing. Okay, so I will first try to give you a pictorial representation of this. Okay, so let me first give you a pictorial representation. Think this is our ground level. This is the ground level. Okay, this is ground. So on this ground, now think there is a lamppost. There is a lamppost here, and this is the lamppost. What is the height of the lamppost? It is given as 6 meters. The height of the lamppost is 6 meters. So here I write 6 meters. Okay, so here I have a, definitely this is, I write this as L and this is L dash. Okay. So here I have a lamp. Here I have a lamp which gives us the light. I have a lamp here which gives us the light. So the height is from here to ground. Here to ground is 6 meters. This whole thing is 6 meters. Now the man is walking away from a lamppost. So now let us make a man. So here I take a man. the man is walking, and what is the height of the man given? The height of the man is 2 meters. So, from here to here, this is 2 meters. This is 2. Okay. For the sake of simplicity, see, you should have no need to draw a structure the way I drew it. You should have drawn just a straight line. So for making it more simple, what I will do is I will write this as M. M for man. This point is M. And here this is M dash. Okay. Now, how do you get the shadow? See, this is the light emitting lamp. So this is the way you will get the shadow. You see this? This is the way you get the shadow. So the man is walking. So this is the way you get the shadow. This is so the length of the shadow is, see, this is, you can call this as, I call this as S. I call as S. Okay, so M dash S is the length of shadow. M dash S happens to be the length of the shadow at any time t. Now, the man is walking away from the lamppost, and as he is walking at a speed of 6 kilometers per hour, I have to find the rate at which the length of the shadow is increasing. Okay, as he will walk away, students, what will happen? As he will walk away, the length of the shadow will increase. I will give you a hint about it. See, right now the man is here. Definitely the height of the man will not increase. He will keep walking this way. Okay, so this is the line which, I have drawn, this line decides the height of the man. Now what happens is, suppose at any instant, suppose the man reaches here. Okay, at that time the shadow will be this big. You see this? The shadow will be this big. If the man is reaching here, try to understand. If the man is reaching here, then the length of the shadow will have grown by this. You can understand? See, now this is the length of the shadow. And how much it was earlier? Earlier it was only this. Check here, it was only this. See this, it is only this. The same has become this big. So as the man is growing, as the man is going away from the lamppost, what you have to do is you have to get the rate at which the shadow of the man is growing. It is increasing. Okay. See, students, what I will do? I will consider this length to be, first of all, I take this length to be x. I take this length to be x from lamppost to man. I take this length to be x. I write this as x meters. This is x meters. And so if I'm taking this as x meters, try to understand when the man is walking, what is happening? This x is changing. See, if the man is at one point in time, if the man is here at m dash, okay, if the man is here, then its distance is x. The next moment when the man is here, what has changed? This x has increased. So as the man is walking away from the post, the x is changing. And what I'm given the rate at which the man is walking. So I can say that the rate of change of x is 6 kilometers per hour. So I will write given d by dt of x is 6 kilometers per hour. It is 6 kilometers per hour. And next what I do is I write here y. See, from lamppost to shadow, or the length of the shadow, I will take it as y. So how big is the length of the shadow? So here I write, this is the length of the shadow. This I write as y. So remember students, what I have to find is, I have to find dy by dt. To find d by dt of y. That is rate at which the shadow is increasing. Okay, this I have to find. So see, how do I solve this? So here I have written the assumption. I wrote let x meter be the distance at which the man is walking from the lamppost at any time t. There is one more assumption that I wish to write, and it is let y be the. I wish to write one more assumption here, and that is I will write it here. Let y be the length of the shadow at any time t. 5 meter. Okay. Now we can start with the solution. See, students, I have dx by dt. You see x here, and I want dy by dt. You see y here. So the idea is, it is problem based on related rates. If you have some rate, you want the other rate, then the two variables, you should get the relation between the two variables. And here, I will get the relation between two triangles. Which two triangles? See, the two triangle is m dash s. Okay, this is definitely triangle, students. Okay, don't consider, because normally, see, this just for the sake of understanding, I drew the head of the man like this. Otherwise, you know, it would definitely be touching this line. Okay, so point M is here. So point M is here. So now here, students, we have two triangles. The two triangles we have are L dash S. So I write here, in triangles L dash S and M dash S. M dash S. What do you notice in these two triangles? See, these two angles are 90 degrees. So they are equal to each other. These two angles are 90 degrees, so they are equal to each other. Then this angle, see, I'm talking about which two triangles? L, L dash S, the bigger right angle triangle, and M, M dash S. Further, this angle is common angle in both. So then these two angles are also equal. So if that is the case, the third and the leftover angle, this angle is equal to this angle. You see this? So what we will write now, we will write directly. I will write the two triangles are similar to each other. They are similar to each other. And I will write the proper order. I write L, L dash S, that is triangle L, L dash S is similar to triangle M, M dash S. See, I took care of order. Why? See, the angle at L, this angle, you see this angle is equal to this angle. So you write L, so you write M. So that is important, L, M. Then the next is angle at L dash is equal to angle at M dash. You see this? Yes. So you write L dash and M dash. And then S. S is what? Common for both. Now we know, students, by the property of two similar triangles, we know it that when two triangles are similar, then what happens is the corresponding sides are proportional. The corresponding sides are proportional. So I will write, therefore, we can write what we can write here. We can write here L dash upon M dash is equal to L dash S upon M dash S is equal to LS upon MS. Okay. Now in this, this LS and MS, I will ignore. What is LS? See, this is LS and this is MS. Ignore this, we are not interested. The rest I will take care of. So here I write, see, just ignore this. L dash, what is L dash? 6 meters. So 6 meter upon MM dash is 2 meters. So 6 meter and 2 meter cancel. What is L dash S? L dash S is X plus Y. You see this? L dash S, that is from here to here. This is X plus Y. Try to understand. How much is this? X plus Y. And upon M dash S is Y. So here you got 1, this is 3, cross multiply. So 3y equals to X plus Y. So you got 2y equals to X. So y equals to X by 2. I write here differentiating with respect to X. Sorry, with respect to T. So I get d by dt of y equals to d by dt of X by 2. So how much do I get? I get here so dy by dt equals to 1 upon 2 dx by dt. And what is dx by dt, students? dx by dt is given to us 6 kilometer per hour. So 1 upon 2 into 6 kilometer per hour. So the answer is 3 kilometer per hour. This is the rate at which the length of the shadow is increasing. So here all of you saw that we found the rate at which the length of the shadow, see this is the length of the shadow, m dash s. The length of the shadow is increasing at what rate? 3 kilometers per hour, which we had taken as y. So we found dy by dt. Now I add one more question to this particular. I add one more question to this question. Okay, let us extend this question. If the question was find the rate at which the tip of the shadow is increasing. See, the tip of the shadow is this. This is the tip of the shadow. Find the rate at which the tip of the shadow is increasing. Try to understand, students. When we are asked to find the rate at which the shadow is increasing, we found the rate at which this m dash s, this length is changing. We found the rate at which this length is changing. But now I'm asking you, find the rate at which the tip of the shadow is increasing. The tip of the shadow, that is the tip of the shadow is here. Remember, when it comes to tip of the shadow, then you will have to find the rate at which whole L dash S is changing. That is L dash S. Okay. When they ask you find the rate at which the tip of the shadow is changing. The tip of the shadow, I'm sorry, it is not changing. Tip of the shadow is moving. Okay. Find the rate at which the tip of the shadow is moving. The rate at which the tip of the shadow is moving is same as the rate at which L dash S is changing. Okay, rate at which L dash S is changing. Now, what is L dash S? L dash S is, my dear students, x plus y. See, from here to here. So we will have to find x plus y here. Okay, we'll have to find d by dt of x plus y. So what will that be equal to? Let me add to this only. So here I will write the rate at which the tip of shadow is moving equals to d by dt of x plus y. That is equal to d by dt of x plus d by dt of y. D by dt of x was 6 km per hour and dy by dt is 3 km per hour. So this will become 3 plus 6, that is equal to 9 kilometers per hour. This is the rate at which the tip of the shadow is moving. I once again apologize. I was saying changing. The tip, for the tip, what is the correct way? We should be saying the rate at which the tip of the shadow is moving. Okay. Now, one more thing here I want to add, students, that see, we are given the rate at which the man walking is 6 km per hour. Okay, and the length of the lamppost and the height of the man, the height of the lamppost and the height of the man was given in meter. So, but I know where you saw me changing the unit. I did not change kilometer to meter or meter to kilometer. Why that? The reason was very simple, that I noticed that I'm getting the ratio of meter and that meter got cancelled. You see this? Meter got cancelled. So even if I had changed the unit of meter to kilometer, say this 6 meter and 2 meters, if I changed to kilometer, it wouldn't have affected our answer. The answer would have still been the same. Okay. That was the reason I did not need it, so I did not change it. I hope the things are clear to you. We will solve 14th question and see what is question number 14. In 14th question, we have A man of a height 1.5 meters walks towards the lamppost. This time the man is walking towards the lamppost of height 4.5 meters at the rate 3 by 4 meters per second. Find the rate at which his shadow is shortening, the rate at which the shadow is shortening, and the rate at which tip of the shadow is moving. The tip of the shadow is moving. Okay. So let us start solving this problem. You will all start doing it now. So as given in this question, 4.5 is the height of the lamppost, 4.5 meters. 1.5 meter is the height of the man walking. The man is this time walking towards the lamppost. And the speed at which the man is walking is given to be 3 by 4 meter per second. So I'm given, see, when the man is walking, this is the point of contact of man with the earth, the ground level. So when the man is walking, it is this x distance which is decreasing. So we are given dx by dt. I write I'm given dx by dt is 3 by 4 meter per second. I have to find the rate at which the shadow is shortening. So I will write, let the length of the shadow be y. This is my assumption. Shadow length equals to y. Y definitely meters. Y meters is the assumption. This is I say. Okay. And the length of the man from the lamppost Vx, that is also my assumption. So I have to find dy by dt. To find dy by dt, this is one thing that I have to find. And the another thing that I have to find is the rate at which the tip of the shadow is moving. See here, this is the tip of the shadow. Remember students, that tip of the shadow moving, it is, there are two rates of change that you will have to add. When it comes to tip of the shadow moving, it is, you will have to find d by dt of x plus y, because the cause of movement of the tip of the shadow is also the man walking. When it comes to only the length of the shadow, remember, the length of the shadow is only from here to here. It is only from here to here. This is length of the shadow. But when it comes to tip of the shadow, the tip of the shadow is moving because of this thing changing, you know. Remember, the man is walking, because of which the shadow is changing, because of which the tip of the shadow is moving. So here we'll have to find d by dt of x plus y. D by dt of x plus y we will have to find. Okay. Or suppose if I had said, suppose here I say on the head of the man, if I say that on the head of a man there is a sparrow, there is a small sparrow sitting. Okay. So a small sparrow is sitting here. Okay. On the head of the, at the top of the head of the man walking. So if this is the sparrow sitting here, the shadow of the sparrow will come here. The shadow of the sparrow will come here. If now I ask you, at what rate the shadow of the sparrow moving? So if it is the shadow of the sparrow, now you understand, you cannot take it as m dash s, because the shadow of the sparrow is a point shadow. It's a point shadow. And remember, the shadow of the sparrow will move. And the cause of that movement is the man walking, at the same time, the height of the man. The movement of the rate at which the shadow of the sparrow moving is because of two things. One is the speed at which the man walking. Secondly, the speed at which the shadow, the rate at which the shadow of the man is changing. So this is d by dt of x plus y. You find this, you get the answer. I'm sure you will get it. We have done one problem, you can solve one on your own. Now we have question number 15 here. It says a ladder 10-meter long is leaning against a vertical wall. If the bottom of the ladder is pulled horizontally away from the wall at the rate of 1.2 meter per second, find how fast the top of the ladder is sliding down the wall when the bottom is 6 meters away from the wall. When the bottom of the ladder is 6 meters away from the wall. So here I have the diagram ready for you. A ladder 10 meters long. So I have taken LL dash as the ladder. Okay, so LL dash is ladder. And what I am given, length of LL dash is 10 meters. This is 10 meters. If the bottom, and this is leaning against a vertical wall. See, you have a vertical wall here and the ladder is leaning against the vertical wall. If the bottom of the ladder is pulled horizontally away from the wall. Okay, so you know this end L dash, this L dash is pulled away. It is pulled away from the wall. So this L dash is pulled away. In this direction, you pull L dash. Now you know if you are pulling L dash in this direction, what will happen? This L will come down. You see this? This L will come down because the length of the ladder will not change. L will come down. So what I need to understand is they're saying that this L dash is pulled away from the wall at a rate of 1.2 meter per second. So see, when I pull this L dash away from the wall, I'm changing X. Right now, I write here, let the bottom of the ladder be X meters away from the wall. So here I write, let bottom of ladder be X meters away from the wall. X meters away from the wall, right? So what I'm given d by dt of x. The rate at which x is changing is what? 1.2 meter per second. Now, what are they asking? They're asking dy by dt. They're saying find how fast. Check. They're saying find how fast the top of the ladder is sliding down. The top of the ladder, which is L, how fast will it start coming down? At what rate will it come? Okay, so I write here this as y. I write let top of the ladder top of the ladder be y meter away from the ground. Let it be y meter away from the ground, right? So my dear students, what I have to find? To find dy by dt. To find dy by dt. Okay. So here, see what I will write. I'll write here. I know dx by dt and I want dy by dt. So it is Pythagoras theorem that will get me the relation between the two. Remember, the relation between the two is very important. The relation between the two is very important. So what I do here, I write here that dy by dt is I write in triangle L O L dash. Let me write here O. Okay, this is O. So I write in triangle L O L dash. in triangle LOL dash, x square plus y square is equal to 10 square. So y square is 100 minus x square. I differentiate this with respect to t. I write here differentiating with respect to t. So d by dt of y square is d by dt of 100 minus x square. So I got 2y d by dt of y. Y square derivative is 2y d by dt of y equals to derivative of 100 is 0 minus d by dt of x square 2x d by dt of x. D by dt of x square it is. It is not d by dt of t square. It is d by dt of x square. Got it? So now here we will have therefore 2y dy by dt equals to minus 2x dx by dt. With 2 and 2 cancels. I got dy by dt equals to minus x upon y into dx by dt. This is equation number 1. So I want dy by dt and I got that dy by dt would be this. But here very important question is that dy by dt I'm getting minus x upon y into dx by dt. So here I need to understand that what do I do for, see, dx by dt I know it is 1.2 meter per second. But what about this x and y? See, very clearly they have mentioned that you need to find how fast, the top of the ladder is sliding down the wall when the bottom is 6 meters away from the wall. So this bottom is 6 meters away from the wall. They have given you that x is 6 meters at the time when you have to find the rate of change in y. Okay, so you have to find dy by dt when x is 6 meters. So remember, when x is 6 meter, what will be y? That also we will find out. Okay, so I write here when x equals to 6 meters, see here, I substitute in this. Y square is 100 minus 6 square, 36. So y square is 64. Y is definitely not negative 8, positive 8. So when x is 6 meters, y is 8 meters, and then I substitute all this. Therefore, we get what we will get dy by dt equals to negative x is 6 meter, y is 8 meter, meter cancel, and what is dx by dt? Dx by dt is 1.2 meter per second. So this is 2 3s are 2 4s are 3 by 4. I got 3 by 4 into 1.2 minus this will have to multiply. So we will get 3 by 4 is 0.75 and this is 1.2. So we are getting 0.9. See, this two when you multiply get 0.9 meter per second, and that too negative. Now what does this negative sign indicate here, students? See, negative sign is indicating that y is reducing. You see this? When you are pulling this bottom away from the wall, this L, which is top, it is coming near to y. So y is decreasing. That is why the rate of change, y is decreasing. That is why the rate of change of y is negative. I hope you followed it. The rate of change, that is why you are getting negative. So you can write here, the negative sign indicates that y is decreasing, right? Y is decreasing. What you will write, the negative sign indicates that y is decreasing. You can write a note here. The negative sign indicates that y is decreasing. When a variable is increasing, the rate of change that it would show will be positive. Otherwise, it will be negative. I hope you followed it.